Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
Hi, I'm Brylee. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Nicely done, Brylee. So let us know where you go to school.
Panama Elementary.
And what grade are you in?
5th.
And how is 5th grade?
It's good.
Is everything good about 5th grade? Or is anything better than something else?
I think it's all good.
I think it's all good.
Yeah.
Do you have a favorite topic or subject that you like in 5th grade?
Probably reading.
Okay, so are there certain types of books you like to read?
No, any book.
Any books. So you just like to read all the time?
Yeah.
So you go to the library a lot often, right? Huh?
Yeah.
All right, good. So are there any books, like do you guys do core lit books in your classroom where you read chapter books together as a class?
Yes, we do that.
And are you doing one now or have you done one this year?
We're doing one right now.
What is that, do you know?
Zora and me.
And how do you enjoy that right now? Do you like it?
Yeah, I like it.
All right, good. Have you read ahead in it?
No.
Okay, good. We don't do spoilers here, so. that's
So
good.
what kind of math are you doing in class right now?
We're doing adding and subtracting fractions.
And you feel pretty comfortable with that?
Yes,
Do you like the unlike denominators or like denominators?
unlike denominators.
You like unlike denominators?
Yeah.
Well, that's pretty good. You like unlike denominators, but anyway. So we're going to do a little bit of that later on also, okay?
Okay.
But first, I need you to help me with our social media problem of the day. You ready? All right, let's take a look at it together. It's going to be up on the screen. So it says convert to a simplified fraction. So do you know what a simplified fraction is or what it means?
Yes,
What does that mean? What do you think of when you see that?
it's a fraction to the smallest form.
Okay, so in the smallest form. So can you think of one offhand?
2/4,
All right. And what would you simplify 2/4 to be?
1/2.
1/2, excellent. So you know exactly what simplified fractions are. So now we have a decimal up there though. So how can we turn a decimal into a simplified fraction?
We can take the numbers and the 0. If it has 1 0, that would be in the hundreds.
Okay.
So what would you like to do? How are we going to solve this problem? Do you have an idea where to start or which one of those 4 options would be the correct answer?
A.
You think A. So 75 over 100, because if we have 0.75, the 7 is in the tenths place and the 5 is in the hundredths place. So we have 75 hundredths,
Yes.
correct? And that does say 75 hundredths in A. So you are correct with that. But it says convert to a simplified fraction. So is there any way to make 75 over 100 simplified?
Find a common number.
And what do you think a common number would be between 75 and 100?
We could try 5.
We could try 5. So what would happen if we did, and what would you like to do with the 5?
Divide.
All right, so we're going to divide both of those by 5. So if we divide 100 by 5, what would we get? How many times do you think 5 will go into 100?
So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 20.
20 times, perfect, all right? And 75 will be 15 times.
Yes.
So right now it would be 15 over 20, which is what C is.
Yes.
So that would be simplified, wouldn't it?
Yes.
But do you think we can get even
Smaller.
simpler?
Yeah.
Smaller than that? So what do you think?
We could do 5 again.
We want to do 5 again?
Yeah.
All right, so then what would we get?
15 divided by 5 is 3, and 20 divided by 5 is 4.
So that would be 3/4.
Yes.
You think anything up there is smaller than that?
No.
So you did an excellent job by dividing by 5 each time. If I said I have 75, that's like 3/4 of something, 75%,
Yes.
right? So 0.75 is the same as 75%. If I have 75% or I have 3/4 of something, I would imagine money, right? I have 3/4, right? Does that make sense?
Yes.
Okay, out of $1. So instead of dividing by 5, you could have divided by 25 if you wanted to. Does that make sense to you?
Yeah.
Which is kind
So
of
that's
what we
just
did
a
there, right? When we
quicker way
divided
of
by
getting
5
there.
and 5 again.
Right?
Right.
But you did a perfect job by, first of all, going 7/500ths. Now, B is up there. Why do you think B is up there? Because we didn't hit any of that, right? We hit A, C, and D.
Maybe it's up there to throw you off.
It is. That's exactly why it's up there, to throw you off, right? That's why all of the other ones are up there, because out of the 4, only 1 is correct. And the other 3 are to throw you off. So we're going to go with D as the final answer?
Yes.
All right, let's take a look and see if indeed D is the final answer. It is. There you go. Nice going, Brylee. All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, Math in the News today has to do with something that we all have probably in all of our kitchens, black utensils. And we're going to see what this has to do with math. So, spatulas. There are a lot of times people have non-stick cookware, and you don't want to use metal utensils when you're using that type of cookware. So in October, there was a study released stating that black plastics found on kitchen utensils had a toxic flame retardant linked to a cancer in those materials. So it was estimated that there was an intake of 34,700 nanograms of this material that would equal out to 80% of the EPA's limit. So obviously everybody was like, whoa, this is way too high. You can't have something like that, especially if we're cooking with it, touching our food, going into our bodies. We can't have something like that linked to cancer. So everybody was up in arms because this had so many nanograms of this flame retardant in this material. So what happened? It was all a mathematical error. So what happened was they didn't put it to the correct power of 10. So they said it was 34,700 when in fact it would have been higher by another 0. So when you take 7,000 nanograms times the average adult weight, 60 kilograms, you are allowed 420,000 nanograms a day. Otherwise, that would have been 42,000 the way they were calculating it, and saying 34,000 was 80% of that, which then caused an alarm with everybody. So everything was thrown off because of the power of 10. Now, that's simply a 0, but 0 is rather important, and we're going to take a look. One of the instances where you deal with zeros a lot is with the metric system. So if we have 3 meters, how many centimeters do we have? Well, with the metric system, we have the base unit. We're going to go with meters right there. Then we can skip. We have deca, and then we have kilometers all the way at the end this way. Here we have decimeters, centimeters, millimeters. Here, if we're starting with meters and we have 3, we're obviously going to have more because this is getting into a smaller unit. So centimeters, which is right here, we'll just put a C. If we're moving over one place, we're going to add a 0. If we're moving over another place, we're going to add 2 zeros. So we now have 300 centimeters would make up 1 meter. If you didn't know the powers of 10, somebody might go, oh, centimeters is right there, so it's going to be 30 centimeters. Or if they went one further, they would have 3,000 centimeters. And if you only need 300, you obviously can see the big difference in that. That's all because of the powers of 10. Powers of 10, very important, especially when you're talking about scientific things, things going into our body and then publishing it out for the public. An incorrect thing with simply a 0, which has a lot of power. That is today's Math in the News. We'll be back with more right after this.
Hi, I'm Marylou, and we are here again talking about patterns. And I'm with Penelope today. How you doing?
Good, how are you?
Good. Okay, so I have a problem for you. Ready?
Really?
Yeah. So we are going to start with any number, and then we're going to write it as a word, and then we're going to count the letters and continue. And we need to know, why does it always end with the number 4? So here's an example. We started with the number 39, and we spelled it out. 39, and it has exactly
10 letters.
Yes. So we're going to write the number 10.
Mm-hmm.
And 10, the word 10 has how many letters?
3.
Okay. So we write the number 3 in word form, and it has how many letters?
5.
5. So we write the word form 5. How many letters?
4.
And we write the number 4. And that's where we stop. So again, thinking about this, so pick a number for me, any number.
25.
25. Okay, so we are going to write the word 25. And Penelope,
Yes.
how many letters does the word 25 have?
10.
10, okay.
Wait.
Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are correct. And then the word 10 has how many letters?
3.
Okay. The word 3 has how many letters? Or spell it out.
5.
Has 5. And the word 5 has how many letters?
4.
Did we end at 4?
Yes.
We did. Because we're going to keep repeating that 4, right? Because 4 has 4 letters. And so we're going to keep repeating that. Can you give me another letter, another number?
Okay, I'm trying to find the one that probably, I hope that it won't have been 4.
Okay.
36.
36. Let's try that. Okay, think about how many letters 36 has.
Okay.
How many letters?
We got 1, 2, 3, 4, 5, 6, 7, 8, 9.
9. Okay, so it has 9. And 9 has how many letters? 4. What?
How does that happen?
How does that happen? What do you think? Why are we continuing to stop at 4?
Maybe because, I don't know.
Kind of, it's fun, huh? It's like to think about why that happens. Well, we're going to have you guys think about, why does this happen? Why are we always ending at the number 4? Try a number out. Pick any number. Try it out and see what happens. And that's it for today with patterns.
Nicely done. And that is a lot of fun, starting out with any number and seeing why it always ends up at 4. So Brylee, I know that we were going to have you work on some fractions, and we're going to have you work on some fractions, but we're going to have you work on one of those numbers right there.
Okay.
Sound good?
Yes.
That's excellent. The attitude, exactly what I want to see, because I'm sure Devin was kind of like, all right, what exactly are we going to do here? But as soon as you're good with it, then we're going to roll with it. All right? Head on over to the board, sister. All right, Brylee, think of any number you like. Give me a 2-digit number.
13.
13. All right, so Devin, write out 13. And then what you want to do, Brylee, is count how many letters are in that number.
So how many letters are in the word 13?
2, 3, 4, 5, 6, 7, 8.
8. So
Okay.
we have 8 letters in
So
the
you're
word
just going to
13.
write number 8. So the way this works is, no matter what number you start off with, you're always going to end up at 4.
If we keep doing this. So let's take a look at how many letters are in the word 8.
1, 2, 3, 4, 5.
5, okay? So I think we ended up in one of the examples that Marylou had earlier with 5, which is getting us where we are right now. So how many letters are in the word 5?
4.
And that is where we ended up.
So Brylee, can you think of another 2-digit number, maybe higher than 13, and see if it comes out to be 4 again?
45.
45. Now, we're not including the dash here, right? That hyphen does not count as
Correct.
one of our letters. So we're just counting the letters here in 45. So how many letters are in the words for 45?
1, 2, 3, 4, 5, 6, 7, 8, 9.
9. All right, let's go ahead and write the word 9. And how many letters are in the word 9?
4.
And we're back at 4.
So that one
Yeah.
happened pretty quickly. So we'll give
Yeah.
you one more shot at it.
Let's go. What's the longest worded number between 1 and 100 you think you can come up with?
100.
100. Okay, let's try it. 100. How many letters are in the words for 100?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10. I think we saw a 10 up there too during that segment, but let's go ahead and work that through. All right. How many letters are in the word 10?
3.
How many letters are in the word 3?
1, 2, 3, 4, 5.
5. And then how many letters were in the word 5?
4.
We are there once again.
So see, no matter what number you start off with, it's always going to come down to 4. Always. So this is going to be something I want you to think about, just like we had on that little clip right there about kids at home, trying to figure out why does that happen, that every number you come up with, when you spell it out and count the number of letters in it and keep going, it will always end up at 4, because once you get to 4, you're done.
Now, does this work in every language?
We're going English right now. If you want to expand into different
We're going
languages.
to take
I'll
shortcuts
get
and
back. Yeah.
pivots here. Let's take
Clear
a
the
detour,
board, brother.
huh?
Clear the
All
board.
right. New page. Let's go to the start. Okay.
You having fun like Cece did yesterday with that board right there. All right, so you guys are going to start working on fractions right now.
Let's go ahead and...
So Brylee, I want you to explain to Devin anything that you know about fractions right now, and you guys are going to go from there.
Some have common denominators and some have not unlike denominators.
Okay, so let's come up with some examples of common and unlike denominators. Let's start off with a set of fractions right here, okay? Explain to me 2 fractions that would have common denominators.
3/4 and 4/4.
Okay. And I appreciate that you went with 4/4. Even though it does equal out to 1 whole, it still does represent itself as a fraction. Okay, these are common denominators because, as you said, they have the same denominator. If we were to break a whole into parts for each of these fractions, they would have the same number of parts. Okay, go ahead and write down a set of unlike denominators over on your side. So we have 2/4 and 3/6, and you chose a very interesting set of fractions to show, because even though the denominators are different, the value of these fractions is the same, correct? So if we were to simplify or show models of each of these fractions, 2/4 and 3/6, they would both be equivalent to how much?
1/2.
1/2. So even though they have unlike denominators now, they can be made to have the same denominators by reducing them. Now, that doesn't always work with every fraction. Sometimes you have to change the way that you split them up so that the fractions can have a similar denominator, right? So let's say, for example, I had 2/3 and we had 3/4. These 2 fractions have unlike denominators, right? What's one way where we could represent each of these fractions so that they do have a common denominator? What's something we could do with 2/3 and 3/4?
We could change the denominators.
Okay, so if we're going to change the denominator, we have to do something else with the fraction eventually, right?
Yes.
So let's think about this. What would you like to change the denominators to?
4.
Okay, we're going to change both of the denominators to 4. Well, we don't have to do anything with 3/4 then. what are we going to do with 2/3? So if we are going to take 2/3 and represent this fraction as fourths, what does that mean for the denominator? Keeping in mind we want this to have the same value, right?
Yes.
Is there something we could do? And by the way, if not, we can start over and try something else. Okay, that's the beauty of math, is that you don't have to continue down a path if you're not confident it's going to work out. We can try something else.
Let's try something.
Let's try something else. Here's what I would like to try, okay? How can we show what a fraction is worth? Aside from just numbers, could we draw examples of fractions?
Yes.
Let's go ahead and draw fractions. I love using models when it comes to fractions because it helps us understand how much one of these can be worth. So if I take a rectangle and I break it down into thirds, how many of these thirds would I fill in to have the equivalent of 2/3?
2.
2, great. Let me go ahead and I'll just yellow in 2 of these thirds. Each of these is 1/3. I have 2 of them. Great. Now, if I was to take the same fraction, let's say another 1 whole rectangle, let's get that the right color here. And I was going to split this into fourths. Let's say lengthwise here. How many of these would I fill in to have 3/4?
3.
3, okay. Let me use a different color here. Let me go ahead and color these blue. So 3 of these fourths would show the same 1 whole represented in fourths as opposed to thirds. Now, we want to show how we can turn both of these into fractions that have a like denominator, which means we have to find a way to split each of these rectangles into the same number of parts so that we can count how many of those parts fill in the whole rectangle. If we have 3 parts on this one and we have 4 parts on this one, is there something we could do with each of these rectangles to split it into the same number of parts in both?
We could do 2 parts down on that one.
So you're going to do 2 lines down here, right?
Yes.
So basically overlap some thirds, just like over here.
Yes.
So then what could we do on this one?
We can make 3 lines across.
So we're going to make 3 lines across so that we create fourths on top of the thirds on this one. Now what you've done is you've created how many parts in each fraction? So how many parts in each whole do we have now? We don't have thirds here anymore. We don't have fourths here anymore. How many pieces is each of these bigger rectangles broken up into now?
12.
12. So now we have a common denominator, 12. Now, how many of these 12ths in our first rectangle are colored in yellow?
8.
8, right? Because 2 out of every 3 equals 8 out of the 12 total. And then over here, how many 12ths did we have for our 3/4?
9.
9. Because 3 out of every 4 were colored in. So we've taken unlike denominators, and now we've created both of those as a set of fractions with a common denominator. That's wonderful. And now that they're a common denominator, what are we able to do with these? Much more easily.
A multitude of things. You could add them,
So
subtract
many
them, multiply
things.
them, all sorts of things. But for now, you got those common denominators. Nicely done, Brylee. So for some great problems right there, you've got yourself a ice cream of your choice at Sweet Fix Creamery. So congratulations on that. I was going to say a meal, but ice cream can be a meal sometimes, but it's that good over there. So congratulations on that. Hopefully you'll find the flavor because they have all sorts of different flavors. Do you have a favorite flavor of ice cream right now?
Vanilla.
Vanilla. All right. Well, you know what? They've got vanilla, and they've got a lot of different types with vanilla in it. So hopefully you find one that you like, and we'll be back with more right after this.
Is there water on Mars? The short answer is yes. Now we have to think about how do we actually define water? It's not quite like on Earth, but it's definitely there. Water is a molecule that has 1 oxygen atom and 2 hydrogen atoms The ice on Mars is a little bit different than on Earth. On Earth, usually the ice is just, water ice, but on Mars it's actually water ice and CO2 ice mixed with each other. On Mars it's just so cold that it gets frozen. So you actually have those mixed together, both at the poles and underneath the surface as well. We even have water in the atmosphere as a water vapor. It's a very small amount, but it's there. We also have water inside of rocks. So you can think about rocks as sort of a stack of layers, and sometimes there's water trapped in between those layers. And we've actually measured this with a lot of the different missions from NASA, and that's actually what I study. And the last potential state of water is, do we have liquid water on Mars? The answer is we haven't really observed it. We do see these dark streaks on some hillsides that we call recurring slope lineae. One idea is that these slope lineae could be formed by the flow of liquid water, but there's also other ideas where you actually don't need liquid water to explain the formation of these dark streaks. Maybe they could form through sand flow or that kind of thing. So is there water on Mars? Not quite like the oceans we know on Earth, but it's definitely there.
All right, welcome back in studio with us now. We have Sarah. How are you today?
Hi, I'm great. Thank you for having me.
So welcome back, I should say.
Yes,
So
yes.
do you remember the last time you were here?
I do. It was 4th grade. I felt so special. My teachers...
You were special. You still are special. So what do you mean?
Thank you. I was chosen out of the students at Reagan Elementary to come and be on the show, and it was so exciting and very fun.
Well, good. I'm glad you had a nice experience when you were here. Do you remember any of the math problems that we worked on?
Not the problem specifically, but I remember working on fractions, and then when we did the segment at the Bakersfield Museum of Art,
Right.
we looked at the different art pieces and the geometry, the symmetry, the different angles, and things like that.
All right, good. So that is one of the photos from the Museum of Art right there. And then I think we have another photo of when you were on the set. So let's take a look. You know what? Because other than photos, we've got a little something else.
Yes.
So let's take a look at this.
Okay.
In studio with us right now, we have Sarah. How are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I am in 4th grade, and I go to Ronald Reagan Elementary School.
So you are a patriot.
Yes.
And have you been at Ronald Reagan Elementary School for a long time?
Since kindergarten.
Since
yes.
kindergarten. I only have one job left for you. You are now our newest ambassador. Do you know what that means?
No.
What that means is you have to wear a uniform to school from now on. This is your uniform. Let's take a
Okay.
look right over there at camera 3. This is your new uniform. You need to wear the Do the Math uniform to school every day that you go to school. Are you
Okay.
cool with that?
Okay.
Okay. Well, that's good that you were okay with everything right there. So that is 10 years ago, almost to the day
Wow.
that happened right there. So I appreciate you coming back in, because recently I saw you in a musical,
Yes.
and you were working with the Boys and Girls Club with that musical. So
Yes.
tell us a little bit about that.
Yes, that musical was called Six the Teen Musical, or Six the Teen version of the musical. Very fun. Six is currently on Broadway. It's about the 6 wives of Henry VIII.
Right.
And they all have their own songs and stories to share. And at the end of the show, yeah, there's the picture. At the end of the show, they all come together and realize that they are one. They're all their stories are important, but they should celebrate each other and the friendship they have.
Yeah, and it was great because I went to go see the show and I had no idea that you were in it. But then I was like, well, there's Sarah up there. And I didn't realize, hey, you were a guest on Do the Math and stuff like that. So here we go with some of the show.
Oh, wow, yeah. And there was my group, Music Fusion. We were performing the national anthem at the CSUB women's basketball game, and that's where I reconnected with you, and now I'm here.
So you've been doing a lot of things with the Boys and Girls Club.
Yes.
And how did you get involved with them?
Well, I've been doing the workshops with Stars Theater in town since I was 7 years old. And in the past few years, they have collaborated with the Boys and Girls Clubs. And I've been doing those workshops too. They go from 6 to 18, so many years that I was doing them. And the summer before my senior year of high school, I was asked to be a part of Music Fusion, which is the performance group with the Boys and Girls Clubs. Right. And now currently I'm an intern and I actually work at those summer workshops with the kids.
There you go. And they're nationally known throughout the Boys and Girls Club.
Yes.
Right, because they do have them travel to different places around the country to perform.
Yes.
Which is how great you guys are in that group. So let's talk a little bit about the math that you've been doing since 4th grade.
Yeah.
So some of the courses you've done, things that you can tell us about some of your mathematics since then.
Yeah. Well, the last math class that I took was a statistics class at CSUB, Cal State Bakersfield, where I'm a student now. But it's really interesting to think about, as a performer, how much I use math through theater and through performing. It's really fun to see directors when they are creating a show. They want to make visually appealing formations on stage, right? So you have to work with different shapes, either lines or triangles or squares, or maybe you're with a partner in clumps, so that's really fun. When you're reading sheet music, you have to look at the different notes and think, okay, how long do I need to sing this note? How long do I need to hold this note? Dancing, you need to think about the different beats, how long you can hold a pose or do different dance moves. And even the people who aren't necessarily performing on stage with you, people who are technicians and who are building the sets, they need to think about, okay, let me measure this area and see how tall I want my set piece to be. How can I put this platform here? How can I fit it in this space? How can I paint this certain design on stage? How much room do I have? So there's so much math that is involved in performing. It's really fun to think about.
Right, I was going to say, because when Erica was here with the Bakersfield Ballet, same thing, talking about all that math that people don't quite realize that goes into all of these things that are theater and the arts and things like that. Right. So I'm glad you've had some great experiences with it. I'm glad that you're being very successful right now. And as far as, that's the last class you're taking as far as mathematics at Cal State?
Yes, I'm actually an English major at Cal State.
Okay, I was going to say, because you
So
do have to take some mathematics, regardless of what you were majoring in. So let's talk about what you've got coming up with Sioux School Junior here.
Yes, this is our current summer workshop. So registration starts January 15th. I will be one of the instructors with the morning cast. So from 9 to 12 in the morning, I'll be working with those students. And it's a really fun experience. Like I said, I've been a part of these workshops from the time I was 7 years old all the way up to 17. And so now I'm working them, and it's really a full circle experience, but it's so much fun.
Well, good, and that's a passion of yours. You enjoy doing it. It's something that you've grown up doing. You're comfortable with it, and now you can apply it to the beginning of a career with that also.
Yes.
So Sarah, thank you very much for coming in. It's always great to see students come in from the past. I know that we've had a lot of students, because this is our 23rd season, that have been part of Do the Math for many, many years, and then come back and let us know how they're doing, how they've used mathematics in their life, different courses that they've taken and things like that, and what they're doing nowadays. So thank you very much for coming in.
Thank you for having me.
And I said one of those things, once a patriot, always a patriot. So
there you go.
Those days of Reagan right there?
Yes.
All right, thank you very much. Hey, we'll be back with more right after this.
A desire to understand human behavior drives the work of social science research assistants. They study the way people interact, make decisions, and respond to their environments. The work of social science research assistants helps us gain insight into how people look at the world and can help solve social problems in organizations, communities, and countries. Social science research assistants help social scientists conduct research in laboratories, conduct surveys, and categorize data. They also help prepare graphs, reports and presentations, and document findings for publication. They need strong skills in programming, data entry and validation, and statistical analysis. They also need to communicate effectively with a variety of people, including coworkers, supervisors, and research participants. About half of social science research assistants work at colleges and universities. Other major employers include scientific research and development services, government, and social advocacy organizations. Most social science research assistant positions require a bachelor's degree. Some positions also require several years of related work experience.
When people interact, form a group, or work together, they create relationships and, eventually, culture. Sociologists study interactions between groups of people, how human behavior changes over time, and what makes organizations and cultures succeed or fail. Sociologists collect survey data, make observations, and perform interviews to test their theories about human social interactions. They analyze the data and present their findings in written reports or presentations. These social scientists may collaborate with and advise policymakers, other social scientists, or groups that seek answers to sociological issues. Sociologists may focus their research and study efforts in one of many social topics, including health, education, racial and ethnic relations, the labor market, families, gender, poverty, crime, or aging. Sociologists typically work in an office full-time. They may travel to conduct research or present their results at conferences. Most positions require a master's degree or PhD. Applied, clinical, and professional master's degree programs prepare graduates to perform sociological research in a professional setting. Many students who complete a PhD in sociology become college-level instructors. Other PhD graduates lead research for nonprofits, businesses, or government. More entry-level positions in related fields such as social services, education, or public policy may be obtained with a bachelor's degree in sociology.
And right now we're going to take a look at a little bit of math around the world. And for Math Around the World today, we are pleased to have Sanvi in studio with us today. How are you, Sanvi?
I'm good.
Thank you for coming in today. And Sanvi, where do you attend school?
I go to Highgate Elementary.
All right. And you had to do a project based on different cultures and different math from different parts of the world. And what was it that you studied?
I studied how Navajo math works.
All right. Well, go ahead, Sanvi, take it away and let us know all about Navajo math.
So you might be wondering, what is Navajo? Navajo is a Native American tribe spread along bits of Arizona, Utah, Colorado, and New Mexico. They're known well for their handmade rugs and silversmith work. And it also has something to do with their math. Today, over 300,000 people live in Navajo, making it the second most populous Native American tribe in the United States. So how does Navajo math work? So in Navajo, they use a different method from us. However, they use a base 10 number system just like we do. They use something called a math circle, and this is one of them. It's used to help with lines of symmetry and all these operations on here. And this helps dive deeper into your math. So how is Navajo math different from our ordinary math? In Navajo math, you use more geometry, but they still do the operations like adding, subtracting, etc. the same way we do. They just use geometric shapes. For example, they use this puzzle right here related to lines of symmetry. And then for our normal math, we learn how to do something like 2 by 2 digit multiplication. But first, our teacher teaches us how to do it, and then we do practice word problems like this one. How is ancient Navajo math different from modern day Navajo math? Ancient Navajo math and modern day Navajo math aren't very different from each other. The only difference is that the normal Navajo math uses a base 10 number system, and the ancient one uses a base 20. So a base 10 number system increases by the powers of 10, and a base 20 increases by the powers of 20 in the place values. It is believed that the ancient Navajo people used a base 20 number system because they have 10 fingers and 10 toes, so they could count on them. And then what are base 10 and base 20 number systems? So a base 10 number system is where the powers increase by powers, or the place value increases by powers of 10. For example, in the ones place, it's just 1 or 10 to the power of 0. In the tens place, it's 10 or 10 to the power of 1, etc. And in the base 20, it moves on from the powers of 20. So in the ones place is 20 to the power of 0. In the 20th place, it's 20 to the power of 1, and then etc. So 999 in base 10 would be 9 times 10 to the power of 2 plus 9 times 10 to the power of 1 plus 9 times 1 equals 999. But in base 20, it would be 9 times 20 to the power of 2, 9 times 20 to the power of 1, and 9 times 20 to the power of 0. which is 3,789. Basically, in base 20, they use a dot for 1 and a dash for 5 for numbers less than 20, and they use a shell for 0. But if you want to do a number that's bigger than 20, then you can do these little charts, and on the higher the charts go, the higher the place values go. So this one is just 5 because it's in the ones place, and this one's 20 because it's in the 20s place, so that would be 25. In conclusion, the reason ancient Navajo math is different from modern day Navajo math is because the base 10 number system is a lot easier to understand, and it's more common throughout the world today. And a base 20 system is not quite as common, but it doesn't really matter how you do your math. Everyone has a unique way of doing math.
Well, nicely done, Sanvi. So I'm glad that you had that presentation about Navajo math right there. And I know that you did that for a part of a school project. And did you enjoy or did you like learning about the Navajo math?
Yeah, it was really cool to learn about, and it was a lot different from other cultures that you'd see the math. And it's not, like, Navajo is a unique culture and not a lot of people really know about it.
Right, so now a lot of people, more people do know about it now because of what you just presented right there. So has that sparked any interest? Are there any other cultures or things that you think you might want to investigate as far as mathematics goes because of this project?
So the base 20 system is also related to something called a Mayan system, and I would also like to go into that more.
Good, well, there's something else for you to explore right there. So have you ever heard of, and I'm glad you enjoy doing this because who knows, you, because of delving yourself deeper into some of the different mathematics, may come up with something on your own sometime. Have you ever heard of Fibonacci numbers?
Yeah.
And Fibonacci numbers, can you remember what those are like? Can you give me an example of some of those?
0, 1, 1, 2, 3, 5.
Perfect, right? Because they go in that sequence. Who knows? Because he was thinking about numbers a different way and came up with different patterns. Someday, could be very soon, could be a few years from now, somebody might be going, these are Sanvi numbers that we're going to be talking about, so you never know. So some great work there, Sanvi. Thank you for coming in today and telling us about Navajo math. That is today's Math Around the World. We'll be back with more right after this.
Welcome to Cal State Fullerton, where Titans achieve greatness with resilience, empowerment, and opportunity. Since 1957, our campus has evolved to meet the community's needs with accessible, inclusive, and high-impact education. Cal State Fullerton is an economic and cultural center of Orange County with nearly 40,000 students and more than 300,000 alums. We train thousands of nurses, teachers, engineers, and accountants, and are a major economic driver in the state, powering $2.26 billion in economic activity. Our connections go beyond the classroom. Supportive mentors and industry leaders help student entrepreneurs like Brian Roof create a cloud-based disaster relief software.
Cal State Fullerton has been a huge part of me becoming an entrepreneur and furthering the growth of my business. The faculty here truly wants what's best for us. I'm incredibly fortunate that I've been able to work with this university, and they've been able to help and support me. Traditionally, a computer science student would never get exposure to the business world.
It's been a really cool experience to be able to get this knowledge through Cal State Fullerton.
More than 300 clubs and organizations allow Titans to grow and develop their identities with support and resources from Student Life and Leadership, ASI, and Diversity Initiatives Resource Centers. Programs like Black Community support underrepresented students like Alexis Johnson Folks, who find support from others facing similar challenges.
When I got immersed in all of the, Black support groups here, especially Black community, I felt more motivated to do schoolwork, motivated to, step up, take charge, be resilient. Because when I'm around people that look like me, I feel like motivated, I'm thriving off of them. I'm like, okay, we're gonna do this together. We're going through the same struggles. Black community came in, wrapped me up, and we're going far, baby.
Our 8 colleges create opportunities for students to have an accessible education with intellectually rigorous programs with renowned faculty relevant to the needs of students. We eradicated the digital divide by providing technology services designed to ensure student success. and the experience extends beyond the classroom. Uniquely tucked between some of the most beautiful beaches in the world and the snow-capped San Gabriel Mountains, Orange County's vibrant location safely allows students to explore their passion, which will become their life work. Also, our 26-acre Fullerton Arboretum provides a place for students to explore and learn in nature. From California condors to microplastics in the Pacific to Alzheimer's research, Titans solve real-world problems. Immersive learning provides experiences for students like Evelyn Bond to create an impactful future.
I had no idea you can conduct research as an undergraduate student. And even more beyond that, I really didn't know what research was. I learned about the Southern California Ecosystems Research Program. I dove right into an intensive 3-week summer research course, and it was never ending from there. But within a year of being in that program, I actually felt like a scientist. And it was all the resources that they provided to me, talking to me, helping me figure things out, critical thinking. The most amazing thing that I got from here was self-confidence.
College career specialists help Titans explore, engage, and build their professional network. As a first-generation forward institution, Cal State Fullerton eliminates barriers to graduation with scholarships, success centers, hands-on advising, student emergency funds, and mental health resources. Kimberly Cruz speaks about her experience in the Abrego Scholarship, which provides resources for first-gen students.
I wouldn't have graduated if it weren't for the Abrego Future Scholars Program, and I definitely hope that they continue to mentor, especially first-gen and students of color, because we need more representation, and they opened up their doors. It wasn't just mentorship, but it was also love, it was also support, and it was also just knowing that I had someone to rely on. We come from humble beginnings. My parents immigrated from El Salvador to come here for a better life, and now they can have the honor to say that they have 3 children as university graduates.
Our recently concluded $270 million campaign will continue to pay dividends into the future, guided by a strategic plan that is integrated with the voices, ideas, and wisdom of our campus community. Cal State Fullerton is not transactional. It is transformational. Whether you're a traditional or non-traditional student, Titans evolve together to contribute and solve real-world problems. Empower yourself, empower others. Fullerton.edu.
There we go, another one of the fabulous schools in the CSU system. We have one right here, CSU Bakersfield. In studio with us, though, we have Brylee, a 5th grade student from Panama. How you feeling?
Good.
Feeling pretty good?
Yes.
You had a nice little break right there. Yeah. You're still good with fractions? You didn't forget any of that stuff?
No.
All right, head back on over to the board. You and Devin are going to continue working on fractions, but this time I think you're going to maybe add some, and we're going to start with unlike denominators.
Yeah, so let's go ahead and come up with 2 fractions with unlike denominators. You give me a fraction, I'll come up with a second one, and we'll see if we can add them together, okay?
Okay.
What would you like to do as your fraction to start off with?
2/8.
2/8, okay. Let's go with that. I'm going to go ahead and throw in, let's go with a 2/5. Now, what we're going to do is we're going to add these fractions together. Okay. Before we do that, if somebody was trying to figure out how to do this on their own and they haven't been taught how to do these yet, what do you think they might try to do? Just by looking at these 2. If they were just told, hey, just add these fractions, and they didn't know anything about common denominators or anything, what do you think they might try to do?
They might try to add the denominators?
Yeah, so they might try to do 2 + 2 is 4, 5 + 8 is 13, and get 4/13, which is not equivalent and it's not a functional way. So sometimes it's important to know what not to do, right? So let's talk about how we can figure this out. In order to add these 2 fractions, what do we need to do with them?
We need to change them.
Yeah, we need to change them so that they both have what?
The same denominator.
The same denominator. Now, we did this model before, right? Remember when we had 2/3 and 3/4, and we basically multiplied those denominators together to get a common denominator of 12. Well, let's see if we can do something similar. So how would you go about adding these 2 fractions? What way do you know that we might try?
We might try to find a common number for the denominators.
Okay, so a fraction that would be equivalent in fifths and eighths that would have the same denominator. Okay, well, let's think of this. Are there any denominators, are there any numbers that you could divide by both 5 and 8? So, for example, we can divide something by 8, and we can divide something by 5 and get something. But what's that same number going to be? Well, let me ask you this. Is there something we can multiply when we get 5 times 8? What would that equal?
40.
40. Now, if we multiply 40 by 8, I'm sorry, if we divide 5 by 8, we get 40. So if we divide 40 by 8, we get
5.
5. And if we divide 40 by 5, we get
8.
So 40 is a common denominator that we can use for equivalent fractions of 5 and 8. So let's try this, okay? If we are going to change 2/5 into 40ths, we're going to have to do something with this fraction, right? We're going to have to make it equivalent. What did we do to 5 to get to 40? We multiplied it by what?
40. I mean 8.
8, right? So whatever we did to that denominator, we're going to have to do to the numerator up top here, right?
Yes.
So we did 5 times 8 is 40. 2 times 8 will equal
16.
16. So 16/40ths is going to be our equivalent fraction of 2/5. I'm going to go ahead and just put 16/40ths up here, okay? Just so we can reference that. We'll work on it a little bit over on this side. Now let's do this with 2/8. We said that 40 was going to be our fraction. Could you go ahead and put 40 as the denominator over there? Now, what did we do to 8 to get it to 40? What did we multiply that by?
5.
5. So let's go ahead and just put a tiny little times 5 down there, just so we remember. Whatever we did to the denominator, we need to do to the numerator to keep that fraction equivalent. So what would we do to 2?
We would multiply it by 5.
Let's multiply it by 5. So we have 2 times 5, and that will give us 10. So we've got 16/40ths is equivalent to 2/5. We have 10/40ths equivalent to 2/8. Now what we can do is add these because, like you mentioned, Brylee, we have a common denominator. What we're essentially doing is 16 plus 10 over 40. So let's go ahead and work with this. 16 plus 10 would equal what?
It would equal 26.
26. Go ahead and let's write that as our fraction here, right? 26. And what's our denominator going to be?
40.
We keep the denominator. Exactly. 26/40ths. Now, we can leave that as is, but we know a lot of times educators, tests, books, they like us to simplify because it's easy to print one answer than all of the possible equivalents, right? So let's appease them. Let's make a simplified fraction. Is there any number that we can divide into both 26 and 40?
We could try 4.
Try 4. The thing that keeps me from moving forward on 4 is when we added 16 and 10, we could divide 16 by 4, but can we divide 10 by 4?
No.
Not completely, right? So let's scale down a little bit. Sometimes, if we're struggling with a common denominator, we can keep it simple, right? What's the smallest number we can divide both of these by? Just by looking at the last digits.
2.
2. Let's divide both by 2, okay? Which of these would you like to divide by 2 first because it'd be simplest? 26 or 40?
The 40.
Okay, 40 divided by 2 equals?
20.
20, great. All right, let's do 26 divided by 2. How could we figure that out?
2 times 10 is 20.
2 times 10 is 20. I'm going to record your thinking here because I love the way that you're thinking out loud about the pieces. So we have 20 of the 26 with 10. How many more would we have left?
6.
6. So 2 times what will equal 6?
3.
And then we have the combination of 10 and 3 here. 10 plus 3
13.
is 13. So 13/20ths. Is there anything that divides into both 13 and 20? There really isn't, because 13 is a prime number. The only number you would divide 13 by and get a whole number is itself or 1. So we have 13/20ths, which means we took a long way to get there, right? We had to combine our fractions by getting them into common denominators. But then once we did so, we were able to add those numerators and then simplify by reducing by a common factor of 2. So, long story short, 2/5 plus 2/8 equals what?
13/20.
13/20. Now, if we just add across, is there any way we could get to 20ths as our denominator with 5 and 8? Probably not. So that's why it's so important to make sure that when we're adding fractions, we're adding pieces that are the same. You can't add 5ths and 8ths together, but you can add 40ths and 40ths together.
There you go. Nicely done. Some great work right there. Brylee, come on over here. So what do you think of that problem? That was pretty good, huh?
Yeah.
All right, you and Devin did some great work today. So you are now an ambassador for Do the Math. Do you know what that means?
Means I get to wear the Do the Math t-shirt.
That's right. So you were watching earlier when we were talking to Sarah, right? And when she was an ambassador 10 years ago, right, she had to do the same thing as you do, right? So are you going to be able to wear your shirt to school every single day?
No.
No, not
That's
every
a
day.
lot
It's
to
probably
ask.
unlikely you're going to be able to do that. Probably 4 days out of the 5, but not every day, right?
Yeah.
So all you have to do is when you wear your t-shirt, people are going to go, hey, Brylee, what's up with that nice blue shirt you got there? It says Do the Math. What's up with that? So you can tell them about Do the Math, right? And especially you have to go in and tell your principal, because your principal was one that nominated you to come on the show today. You did an excellent job today, by the way.
Thank you.
Do you have any idea what this is?
It's a Rubik's Cube.
Do you know how to do Rubik's Cubes?
No.
No, I don't either. I'm not very good at them. It would take me a long time to get this thing back to the way it originally was. So have you ever tried one?
Yes.
All right, good. Well, you know what? You're going to be able to try this one also, okay? But this one is special. You know what's special about this one? It is a unique Do the Math Rubik's Cube. So I can almost guarantee you that maybe one other kid at Panama probably has something like this, but you're going to be the next kid that has one like this, all right? So hopefully you have an opportunity to check that out. Don't forget, the Stage Door Academy's got Susical coming up. Sarah was talking about that earlier this afternoon. She is now an employee working with students as she was growing up in the theater, and with much help from Do the Math, I can assure you with that, but who knows? Anyway, Sarah had a great time with the theater, and now she's helping out with students, and that is coming up January 15th. You can sign up for that. So, did you learn a little bit of something today?
Yes.
What kind of things did you learn? Do you remember anything that you learned today?
I learned that usually I don't really make a model. I usually do it the way that I did it just now.
Okay.
So I learned that I can make a model.
Right, and there's a lot of different ways you can do math problems, right? Because somebody might go, you know, here's the math problem that we're working on, and then you can go, I do it one way, and somebody else in class goes, I do it another way. And let's say you have 28 people in your classroom, there's going to probably be 28 different ways to do that same math problem, right? And the more ways you develop on how to problem solve, the better off it's going to be later on. Did you have fun today?
Yes.
That's the most important thing right there. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.